Hello everyone and welcome to .NET Core Central. In today's video, I'm going to talk about reflections in .NET Core. Reflections is a feature provided by .NET. It's a feature using which we can reflect on an assembly to get the types and other information. By reflect, I mean we can take an assembly and then from the assembly we can figure out what are the different types defined in the assembly, and then inside of each type what are the different methods, properties and fields, and then we can also invoke those properties and fields creating an object, and we can do all of these using reflection and not essentially doing a new on that type. So to demonstrate that, I'm going to create a new .NET Core console application and I'm going to name it as reflection.demo. Now I'm going to get rid of this default console statement. Once the project is created, first let us create another project, and this time I'm going to select a class library and I'm going to name it as print all. So this class library is going to have a class called, let's rename it and let's call it custom print. Let's say this class is responsible for doing printing, but beyond printing also we will have some other functions. So let's define few functions and properties in the class. So first one is a public method, and this one is just going to be print, and this one is just going to do a console.write, and it's going to print out printing from print. And then next one, I'm going to create another public method, and this time it is going to return a string, and it's going to say get name, and it's going to return a variable name, and this name is going to be a class level variable. So I'm going to say private string name. Now after that, now I'm going to create another method, and this time it's going to print the name set. So print name, and it's going to have a console.write line, and it's going to say name set as name. And then I will have another method which is going to be void print, and this one is going to take a name to print as a argument. So here we'll have console.write line, and we're going to say name passed name. So right now we have different variations of public method. One is a void, doesn't return anything and prints out a constant string. Another one returns a private method. Then the next one prints out the private variable that was set, and one after that takes a parameter and prints that out. These are the 5 variations. Then another one, I'm going to have just a private method, and this is also void, and we print private. And here we're just going to say console.write line of printing from private. And then I'm going to have couple of properties. So public string name, and it's going to return the name, and another one public static, because so far I declared all instance methods. So now let's declare a static method also, and let's call it static name, static property name. This has to be string. That's the return type. So now we have this class defined, and this class is defined inside of this assembly, and this is the path for this assembly. So now I'm going to first rebuild this so that the assemblies are created in the bin debug folder. So this is where the assemblies are created. As you can see, print all is created here, so we can copy this path, and then let's start using reflection. So for starting reflection, the first thing we have to do is get a handle of the assembly. So for that I can say var assembly equal to assembly dot load from, and here I can provide the path of the assembly, which is this path I just copied. And then after I do that, let's first start with what are the different types defined inside of the assembly. And for that, I'm going to do a for each and type in assembly dot get types. So the get types is going to give all the types defined inside of assembly. And then what I'm going to do is I'm just going to do a console dot write line, and here I'm going to say type is type dot name, right? So that's the type of the assembly. And then let me create partition because I'll be doing more printing. So first I'm going to get the type defined inside of assembly. For this one, we'll just have one type, which is a custom print. And then next thing is I want to print all the methods, all the fields, and all the properties. First, let me start with the fields. So I'll do a for each field, which is the field at the type level, type dot get fields. And getFields method has an overload which has binding flags, and as you can see, it says binding flags is a bitwise combination of enumeration values, right? So we are going to say binding flags dot, we want non-public because if you remember the name is a private field, so we'll say non-public. And then we'll say we need instance because it's an instance property. Let me get it to the next line. And then we are going to do another operation, and we are going to say binding flags dot declared only, means the items which are declared inside of this type only. And then I'm going to do console dot write line, and here I'm going to say field dot name. So that's where we define the field, and I'm missing a bracket here, so I'll close this. Okay, again after this printing the fields, let's create a delineation. And now next thing I'm going to do is I'm going to print all the functions or methods. So again I'll do a for each. I'll say method in type dot get methods, and here I'm going to use the same set of binding flags because I want all the instance, because I don't have any static methods, I have static property. So for this one, I don't need it, but you get the idea. And then next I'm going to do similarly here. I'm going to do console dot write line, and I'm going to say method is. Now when we print this, you will see unexpected behavior which you might know already, but it will be interesting to see what this prints out, and we'll discuss why it happens and how to avoid that. So after we print all the methods, now it's time to print all the properties. So we can say property in type dot get properties. Here we don't need any binding flag because we don't have to, and we can say console dot write line. It's like before, property is property dot name. So now here we printed out the type. Using reflection, we got the types from the assembly. For each type, we'll print the type name, and then again using reflection, we'll call get fields, print out all the fields, print out all the methods, and print out all the properties. So let's run this. And now we can see for type, we see custom print. For field, we see name. For method, we see only print private. We don't see anything else. And then for property, we see both name and static name. Now let's figure out what might have gone wrong with the method. So for method, the mistake we did is we copied this one, so we say non-public. So let's remove this. Let's make it as public, rerun this. Now all the public methods should come. But now you will see an interesting fact. We got a print, we got get name, we got dot print name, print, these are all expected. But then we are going get underscore name, which is the internal name of the name property. Now we want to escape that because we don't want property to be shown as a part of the method, because that'll cause a problem if we want to invoke those methods. So now how to do that? For that, what we are going to do is here we're going to add a condition here. So we are going to say dot where, and here we get the method as the parameter, and here we can say there's a property declared which is special name, and the special name indicates whether the method has a special name, which essentially says whether it is the properties or not, because only properties have special names. These are defined by the compiler. So now if I run this, I will see only the get name, so I have to do a not of special name, and now if I run, I can see exactly what I expect. So I see get the type, field, all the methods and the properties. Now, well, this is interesting, but it's going to be way more interesting if we can invoke the methods. So for invoking, first we have to create an instance of the type. So now, how do we create an instance of the type? We cannot say new of the type. That's not going to work, right? So here we are going to use a class called Activator. So we're going to say Activator dot create instance. This is the method, and when we create instance, we're going to pass the type for which we want to create instance, and also it has one of the other. This takes assembly name, type name, you can use that also. It takes if it is non-public, and then there is another parameter which takes param, which is an array of object, which you will be using if it has a constructor which takes arguments. In that case you will use that. For us, we don't have a constructor, so we don't have to worry about it. So we'll do create instance, and this is going to give us the instance of this type. Instance. So now we have the instance. Now we have to call those methods on the instance. So first, let's say we want to set the field value so that we can get inside of this method when we are calling like print name, we should be able to, let me just for clarity, let's say this dot name, and here also this dot name, so that it doesn't look confusing with this name here, which is this parameter. Okay, so now if we set the field here, once we set the field, when the print name method will be called, it will print the name that we have set, and also the get name method will return the name that was set. So for setting the field, what we are going to do is field dot set value, and you can see the first parameter is the object, basically the instance whose field it is. So this is the instance that we created, and then for value we have to pass an object. So we are going to name it as Frodo. So we set the name. Now the name is set, and now let's try to call all the methods. Now for each method we want to call the method. Now while calling the method, there are a couple of things we have to figure out, right? Because if you see, one of the method is private, which we did not get yet because we just had public, we did not have non-public. So let's add that also. Binding flag dot non-public, so that we get both public and non-public. And this is a fundamental difference between using reflection versus calling an object directly creating an instance, is that when you use reflection you can access non-public method also, which is pretty dangerous. Now when we print this, but before printing, before setting everything, let's just run and just show the non-public method. If I run this project now, you can see the private print is also showing out, the print private method. So now let's start again. So uncomment this. So we are setting the value, and now for each method, now one of the method is different than rest of the other method. This method takes a parameter, and also this one returns a value. So we have to treat them differently. So for that, first what we're going to do is we're going to check, we're going to put a if condition. So we're going to say if method dot get parameters. So it will return if there are parameters. So we can say if dot parameters dot length is greater than 0, then behave differently. In this case, we're going to say method dot, and for calling a method, we are going to use invoke. And the first parameter of invoke, as you have seen, is the instance. So we'll pass the instance. And the second parameter is an array of object. So we can do like this. And here we're going to pass a value. Now here, this is the only method which takes parameter. It takes a string name. So we're going to say Bilbo. So this is the one if it has parameter. Then the next one, what is the next condition? The next condition is if it returns something, we want to treat it differently. So if method dot return type is going to be void, and that's a type. So we can say return type dot name is not equal to void. Then what we are going to do is var return value is equal to method dot invoke instance, and for the second parameter just pass null. And then here we can do console dot write line, and we can say return value from method, and we can say return value. This is done. So if it has parameter, if it is not void, and then last finally we just invoke the method dot invoke, and here we pass instance, and now that's all the methods. And then finally for property we can say var property value is equal to property dot get value, and here we'll pass the instance. And then we can say console dot write line property value is property value. So now let's go to the code again. So first we did assembly.load from, we loaded from an assembly. There is another method in assembly called just load, which can load an assembly by name, but in that case the assembly has to be somewhere accessible, and that will be if they are in the same bin folder. So we can do that as well. Then we are doing assembly.get types. We're getting all the types, and then we are doing an activator.create instance, passing the type to create an instance of the type. After that we got the fields, and then we're setting the value of the fields. This is a non-public field, and you can see we can set the value of a non-public field using reflection, which is very different from if we are creating an object by using new. And then we are going through all the methods. We're printing the name of the methods, and then we are dealing with the method. If it has parameter, then we pass parameter. If the return type is not equal to void, then we get the return type and print it. Otherwise we are just invoking the method. We deal with all the three cases that we have, and then finally we get all the properties, print the name of the property, and then get the value of the property and print it out. Okay, I have to have else if else condition, otherwise this method will be invoked in all the cases. So let's just put it this way and then close it. Okay, so you should ensure that this method is not called every time, otherwise it will be called every time. So now let's run the application. Now once we run the application, we have all the responses, which is pretty cool. So first method print, and this is printing from print, and this is exactly what we had for method print. It was printing from print. Then we are calling get name, and return value from the method is Frodo. Frodo is the value that we set up here in the private field, and the get name returns the private field, so it is working as expected. One after that is print name, and its name set is Frodo, because print name says name set is this dot name, which is Frodo. This is working as expected. One after that we're calling method print, the overload, passing a parameter. We passed parameter Bilbo, and it says name passed Bilbo, name passed Bilbo. This is working as expected. And the last method is the private method, and it says printing from private. So as we can see, all of these are working as expected. And finally we call the static and non-static property, and for both of them, for static property it is returning the name Frodo, which is the name we set. As you can see here, it returns name for the non-static, and for the static property it is just returning the static property name, which we are returning from here. Now one thing I forgot to mention here is that when we call get value, the instance we are passing, but instance will be ignored if this property is static. You can pass it, you don't have to pass it if you are calling a static property. Same thing goes for method invoke also. If it's a static method, the instance will be ignored. That's all I wanted to cover today. If you like this video, please give me a thumbs up. And if you want me to cover anything more when it comes to reflection, please provide a comment, and I can cover it in the next video, because this is just scratching the surface in terms of what all you can do with reflection. And if you have been following my channel and if you think you are getting value out of my channel, please subscribe to it if you have not already subscribed. Thanks so much for watching this video.